Hello and welcome back everyone. Now we are going to learn about the question thing. So as we have learned the decoders here and along with that we have completed the table. Now it's time to practice one question of the decoder and which kind of the thing that we can expect. So let's write the question first and understand bit by bit that how it's working. Okay, a combinational circuit is defined is defined as follows. So right here we are going to have a combination circuit. Let's take two functions. First one is f1, x comma y as our the input lines, and we're going to get sigma 0 comma 3, and the second function f2, again xy is equal to sigma 1, 2, and let's also take 3. Okay, so what we need to do here is the real question thing is implement the combination circuit by means of the decoder that we are focusing right now. So here we are have to design the decoder and external. Now this is the conditional part, that's why I selected the question. External NAND gate. So in this question we are asked about something. So let's decode this question first one after another and then we will talk further. So there is a combination circuit defined by the function xy. Well, from this conclusion we can say that we have two inputs or we require the two input lines. So we have two inputs. Okay, now as you can see 0 to 3 is here and 1 to 3 is here. So technically we have 0, 1, 2, 3. So 4 output lines. So we have 4 outputs here. So 4 output and 2 inputs as x comma y. That's the information we are getting just right from these two lines. And now it's time to see that what is the implementation condition that we need to implement the combination circuit by means of the decoder. That means we have to work on the decoder because there are the encoders in the future in the coming thing. So that's why it is always mentioned that what is your purpose and what you are actually going to do. So here we need to focus upon the decoder thing. As we have already studied the decoder only, so we will focus on decoder obviously. Now the key point here that we have to take from this all the things is external NAND gate. So we need to use the NAND gate outside our decoder. So this is the most important thing that we have developed here. Now let's start solving it one after another. So let's begin. So first thing first of all we need to make a input and output line. For that let's make a IC diagram because that is quite simple, the very obvious reason for that. And we have here four input output lines, two input and four output lines. So let me also mention so that we can see everything. This is X, Y, and let's name it D0, D1, D2, and finally we have D3. So these are the four input output lines. So these are the inputs that we have here, and these are the outputs. So we have done the first condition. We have implemented the input and the output. So now it's time to do the next thing. According to the question, we need to implement NAND gate outside. So let's see how we can do this thing. So first of all, we need the NAND gates. So let's make the NAND gates first, and then we will start. Okay, so for the NAND gate, I am giving just one input. So I am making it one input line. And for the NAND gate, obviously we make it like this, as we have done in the earlier sections. So let's make it first, and then we will work on this. Okay, we are almost done. So these are our four NAND gates. Now what we need here, as for the NAND gate, it is just acting as the NOT gate right now. Why the NOT gate? Because as you can see, I have not given two inputs or three inputs. I am giving just one input. I have connected these four with just one input. So as in the result, what we are going to get here is D0 dash, D1 dash, D2 dash, and finally in this one we have D3 dash. It means it get complemented, and now it's time to do something awesome. Well, are you excited about this? Well, I am a little bit, honestly speaking. Now what we are left with is the condition, the actual thing. So in the first case, we want 0 and 3 to be active, rest inactive. So what we need to do here is make another NAND gate, as we are only allowed to make the NAND gate according to the condition. But this time we need the thing as 0 and 3 inputs. So I'm connecting with 0. Let me change the color so that we can see it very clearly. 0 and that 3. And here what we are going to get through the NAND gates formula is D0 dash dot, as the AND gate operation type thing happens all the time here. We have D3 dash, and as per our De Morgan's law, we can write it as D naught plus D3. So it means we have just implemented 0 comma 3. So this is the first thing that we have completed. Now we need another NAND gate to fulfill the condition of the second formula. So let's make the NAND gate first. Okay. Now, as you can see, we have implemented the first one. In the second one, we want activation of 1, 2, and 3. It means we want 3 consecutive inputs. So 1 is coming right from here. Let me change the color. 1 is coming right here. 2 is coming right here. And in 3 case, we can just connect it here. And now we can write the result here. Okay, I missed one thing. Don't get confused in that. These will gonna be complement either. Well, either you can show it like this, or you can put the bar over on this. This is pretty much the same. I'm just putting the complement over here. Okay, because the not part is here. So we have to focus that wherever is the not part, This dot part is representing the AND formula, which is the logical multiplication. But because of this not part, we also need to complement our answer. That's why we reached to this result. Okay, I hope you have got it. Now let's proceed. So here we're gonna have d1 dash plus dot. We need to take the dot. We are using the NAND gate formula. D2 dash dot D3 dash and whole to the complement. And as for the De Morgan's law, we can convert it into D1 plus D2 plus D3. And this is our second function, which was speaking about 1, 2, and 3 thing that we have seen right here. Okay, I hope you have got the idea of implementing. So this is for the function 1 and this is for the function 2. Now we have successfully completed using the De Morgan's formula, using the De Morgan's formula that helps to simplify the things. We have implemented the NAND gates. Well, we require more than one NAND gate. We need to pre-plan the things. I'm just going to discuss how we're going to do that. And it's done. It's done. That is it. Now, question is always presented in a format where whichever the gate or logic gate we are talking about, there's always a reason for that, and it will always going to work. You just have to see that how it's gonna work. That's the only thing that we need to focus upon. That's all. That's all it completely. So what we need to focus here is, according to the question, what we first did is just implemented this IC. We just made this IC of 2 cross 4, and this IC is actually our decoder. So I can also write it decoder. So this IC is our decoder with 2 inputs and 4 outputs. Now, as per the question, we needed to work with the NAND gates. So we implemented 4 NAND gate consecutively. Well, why not it worked with just one? Well, it won't. If you even try it, it won't. That's why we have implemented this. So first we complemented all these things and then combined and then again used the NAND gate, because the NAND of the NAND, well, if you remember recalling the thing, we have studied something like this. A complement's complement is actually the element A. So the NAND of the NAND, if you give the input A, it became A dash. Now A double dash is actually became A. So for the target thing, we need to do few simplifications. And as per our convenience, we have took 0 and 3, and then just using the De Morgan's formula we easily got into it. And same in the second case. Well, it's the sigma, that's why it's addition form in the simplified form. And that's all for the decoders. I hope you have learned it, and if you try, it will take few moments to understand that why these 6 NAND gates are used. But if you think from the eyes, from your clever eyes, you will surely learn that these two NAND gates were to implement two functions, F1 and F2. And if you write down these things first, or at least keep that thing in mind and reverse engineer it, you will understand that you actually need to do complement of complement. That's why these 4 NAND gates are here. I hope you have got this. Well, it takes few time. Sometimes it's a little bit not that much easy. So don't think that it's easy or it's gonna be difficult. It's just 2 cross 4. Imagine it's 3 cross 8 or 16 cross 64, that will gonna be complex surely, and it will surely gonna take time to understand these all the things, but the basic key idea is just this simple, and I hope you have understood that completely. So with this, let's wrap up this section and let's complete the decoder with this question. So decoder is done here, and now we're going to proceed on the multiplexer that is waiting for us from a long time. So see you in the next one where we will learn about the multiplexer. Till that time, take care, God bless, and